So, correctness. I claim this algorithm is correct. Hopefully it will surprise no one that the proof approach is by induction on the number of iterations. Well, all the algorithm does is a single loop. It does one thing each time through the loop, so let's just show that each of those is correct, assuming all the previous iterations were correct. So the base case, let me just say, should be clear. So the base case is for just the destination of S. Okay, so hopefully it's clear that indeed the shortest path length from S to S is 0. Remember, we're assuming that edges have non-negative length. Okay, so that should make it ever more obvious that getting from S to S with 0 length is optimal. And the optimal shortest path is the empty path. So that's the base case. So for the inductive step, I guess first of all, what's our inductive hypothesis? Just to be clear about it. So we're going to suppose that some now generic iteration of Dijkstra's algorithm, okay? We're going to suppose we've been correct thus far. What does that mean exactly? What that means is that we've computed all the entries of our A and B arrays correctly for all vertices which are already in our set capital X. Okay? So for the base case, we proved this. For the special case, where capital X is the singleton consisting of the origin. Suppose it's true for some generic subset capital X. And now suppose we're about to add W star to X. Right, so we need to show that our computations for both capital A of W star and capital B of W star, as shown right there, are correct. All right? And this will follow quickly from two observations. First of all, let's look at the length of the path we actually compute. That's step one. Step two is to show that any path must be at least that long. Ergo, ours is the shortest. Okay? So what is the length of our path, the SW star path that we compute? Well, what is the path? I mean, the path is super simple, right? It's just whatever path we'd already computed to get to V star plus this single edge tacked on to the end. Okay? So it's just length of the path we already know how to use to get to V star with this extra edge, which, this is now using the inductive hypothesis on this first part. I'm going to write A of V star. I could write capital D of V star, it wouldn't matter. Remember, capital D is ground truth. Capital D is what the real shortest path length is. Capital A is what we computed as the shortest path distance, but inductively those are the same for any vertex in capital X, such as V star. So don't forget, this was a frontier crossing edge. So the tail of this edge already lies in capital X. So we've already done inductively everything correct for the tail of this edge. We're trying to argue about the head of this edge. Plus the cost of the edge that we tacked onto the end. Okay? So again, that's it. So point number one, there's 2 points. Point one is we just computed our attempt, our guess, at a shortest path from S to W star. It's very easy to understand exactly what its length is. It's just whatever the length it took to get to V star previously, plus this one extra edge on top. Okay?